Right now, a solitary piece of human technology is drifting through the absolute, freezing darkness of the interstellar medium. It is completely alone. At 15.1 billion miles away, the distance is almost incomprehensible. A single radio signal, traveling at the absolute speed of light, takes 22.5 hours just to reach Earth from Voyager's current location. Since leaving the launch pad in 1977, Voyager 1 has been a model of consistency, steadily transmitting predictable streams of cosmic radiation and temperature data back home. That decades-long streak of reliability broke in November 2023. Without warning, the probe's flight data system ceased sending its standard science and engineering readouts. Instead, the telemetry devolved into an unrecognizable pattern. It began broadcasting a continuous, repeating loop of binary ones and zeros, a digital flatline. Down on Earth, the reaction was immediate confusion. NASA's top aerospace engineers were left analyzing a corrupted data stream that defied their understanding of the system's architecture. This anomaly forces mission control to determine if they are witnessing the final mechanical decay of an aging machine or an encounter with an environment we are only beginning to understand. Diagnosing a mechanical failure 15 billion miles away requires navigating 50-year-old assembly language. The original engineers who built the system are largely retired or deceased. The probe's onboard hardware is strictly constrained by the era of its construction. Voyager's entire flight data system operates with less than 70 kilobytes of memory, relying on processing power developed half a century ago. In March 2024, NASA initiated a calculated poke command. They forced the probe to execute a complete dump of its memory back to Earth, enduring a 45-hour round-trip communication delay just to see if the command registered. This schematic shows the interconnected logic gates. Decoding the memory dump revealed a single isolated chip responsible for formatting data had failed. Officially, the chip likely succumbed to 46 years of space wear or sustained a direct strike from a high-energy cosmic ray. Not everyone in the scientific community accepted that conclusion. Independent astrophysicists noted that a simple hardware explanation may not account for the unmapped conditions found within the interstellar medium. A damaged chip provides a clear mechanical answer, but provides little insight into the specific pressures of the deep space environment that may have caused it. Outside official channels, alternative theories began to gain traction. These hypotheses position the chaotic environment at the edge of our solar system as the primary suspect. One major model focuses on the interstellar wall. The boundary where our solar system ends is a dense cosmic plasma compression zone. Passing through these electrical charge variations could scramble primitive logic gates. A more speculative concept is the computational glitch. If physical reality is constrained by a rendering limit, pushing an object past the mapped boundaries of our solar system could return corrupted, unmapped data. But the most unsettling debate stems from the specific payload Voyager carries, leading to the hijack hypothesis. Mounted to the exterior of the probe is the famous Golden Record. It was engineered as an interstellar message in a bottle, a map to Earth, waiting to be found by advanced entities. This introduces what theorists call the primitive interface paradox. If an intelligence did intercept the probe, they would not find a device compatible with modern technology. In this scenario, a high-frequency scan from an advanced entity overwhelms the 1970s hardware, creating a catastrophic feedback loop that corrupts the outgoing data into a distorted binary output. Under the hijack hypothesis, the binary flatline represents the residue of first contact, the unintended result of an alien intelligence attempting to communicate with a primitive human machine. Ultimately, engineers back on Earth managed to execute an astonishing piece of long-distance surgery. NASA operators successfully fractured the software code, bypassing the failed chip and rerouting the system's logic across other functioning pockets of the flight data system's memory. The probe is now transmitting scientific data once again. Yet this victory is merely a temporary stay of execution. Its plutonium-238 generators are steadily decaying. The physical reality is that Voyager's power source is irreversibly dying, shedding essential energy with every passing day. The timeline is absolute. By 2025 or 2026, mission control will be forced to permanently shut down the scientific instruments to conserve the last remaining drops of voltage. As we celebrate the return of normal telemetry, it leaves a lingering question. Did we simply repair a decaying machine, or did we desperately patch over a warning from the void? Regardless of what caused the glitch, the outcome remains the same. Very soon, humanity's farthest traveler will power down for the last time, transforming into a silent, drifting monument in the infinite dark.